Another law that can be successfully explained by Dalton's atomic theory is the law of multiple proportions. Okay, and this law basically says this law has to do with compounds that are made up of the same elements, but the compounds are different. If you were to take the mass to mass ratio of any two elements in one particular compound, okay, and then take the ratio of the mass ratios, then you get a whole number ratio. Let's illustrate that. That's kind of hard to follow. So let's just say you have two compounds, methane and ethene. Okay, methane is a compound that's made up of only carbon and hydrogen. If you were to find the carbon to hydrogen mass ratio in methane, you'll get 2.979. If you were to do that for ethene, which is also made up of carbon and hydrogen, the carbon to hydrogen ratio is 5.5958. Okay, if you take the ratio of these two ratios, 5.958 over 2.979, you get a number that's equal to 2. So you're looking at a 2:1 ratio of the mass ratios. So 2 is a ratio of two small numbers, 2 and 1. So that basically is what the law of multiple proportions says. The ratio of mass ratios of two elements in two different compounds is a ratio that can be reduced to a ratio of small whole numbers. So how do we explain that using Dalton's atomic theory? Well, let's illustrate that with what we now know to make it easier. Okay, let's say methane we now know has a formula of CH4. The carbon to hydrogen ratio in methane is 1:4. And ethene, we now know, has a formula of C2H4. The carbon to hydrogen ratio is 2:4 or 1:2. Okay? So let's say C, little c here is the mass of a carbon atom, and little h is the mass of a hydrogen atom. Then, let's take this carbon to hydrogen mass ratio in CH4. It's going to be the mass of one carbon to the mass of 4 hydrogen atoms, so C/4H. The carbon to hydrogen mass ratio in ethene would be the mass of 2 carbon atoms divided by the mass of 4 hydrogen atoms. So what happens if you take a ratio of these two ratios? So you have C/4H over 2C/4H. Well, what do you get? H cancels. Oops, sorry. 4H cancels, and C cancels. You get 1/2. A ratio of two small whole numbers, which is what we got earlier. We got a 2:1 ratio for if we did methane to ethene. So if you do ethene to methane, that becomes a 1:2 ratio instead of 2:1. Okay? So let's look at this example right here. A compound of elements X and Y is found to be 85.1% X by mass. According to the law of multiple proportion, which of the following mass percent of X is more plausible for another compound of X and Y? Well, let's see. So let's call this compound number 1, and the other compound, let's call that compound number 2. So compound number 1 is 85.71% X by mass. So if I have 100 grams of compound 1, then it's going to have 85.71 grams of X. And how much of that would be Y? That would be the difference between 100 and 85.71, right? 100 minus 85.71 is 14.29. Okay? So the mass ratio would be 85.71 divided by 14.29. So this is the X to Y mass ratio. Is 5.9979. Okay, I have 4 sig figs here, so I'm going to keep an extra digit there, so I'll have 4 sig figs plus 1 extra digit. All right, so let's look at possible choice A. So what if compound number 2 is A? It's 80%, so that's going to be 80 grams X to 20 grams Y. So what would be your X to Y ratio here? 80 over 20, that should be quite simple. That's 5.000. Okay? And the next one is 84.32%. The other possibility is it's got 100 grams of that sample would have 84.32 grams of X. So subtract that from 100. That will give you 15.68 grams of Y. So our X to Y ratio here is 84.32 divided by 15.68. That is 5.3776. Okay? So now let's take the ratio of ratios. So 1 to 2 ratio for A. For A, the 1 to 2 ratio would be 5.9979 is to 5.000. So that's about a 6 to 5 ratio. Okay? The other one is for choice B, your ratio is 1 to 2 would be, actually we're doing 2 to 1, right? Yeah, we're doing 1 to 2. So the ratio of 1 to 2 is 5.9979 divided by 5.3776. Okay, so let's reduce that to a whole number ratio if we can. 5.9979 divided by 5.3776. That's 1.115. Okay, that's not a small whole number ratio. Okay, you can't write that as a fraction using two small whole numbers. So the best answer here is A.